Hello and welcome to the channel. So we've got this Burman, and this Burman's been on the channel before. This is a 501 and the customer built another cabinet for it. The power switch has gone on it this time. It appears to be working now, but it says it won't latch, so we need to look at that. But as well as that, we're going to change some capacitors on the preamp section, and we're going to do the bias trim pot mod. So got three gains on here: bass, middle, treble, presence, reverb for anyone who's not seen them before. We've got a bright switch here, and these are beasts of an amp. Nice leather handle on here. This has been really well covered, real good quality. I don't know whether the customer did this himself or had it made, I can't remember now. So we're going to get this out of the case, and we're going to have a look, get it in the amp cradle. Right, we're looking inside, and yeah, these amps are real top drawer. So we've got these bypass caps here, which are 100 microfarad, and we changed some of them, but we're going to change these to 22 microfarad because the customer wants to try and tighten the distortion up a bit on this amp. So we're going to go for 22s. If you don't like them, we'll probably take them up to 47s. We put 47s on the last one, and it made a massive improvement. But we'll have a bit of a check round. So we're going to do those. We're going to look at this switch, and then we've got that mod to do on there, which we are going to do. Right, I've got it plugged in. Let's see what happens with this switch. Well, that works perfectly. So what's going on there? I don't know then. The amp's on. Not bad. Well, that's working okay. I don't know, I'll have to have another word with the customer on that. Right, so what we're going to do then is we'll make sure these caps are discharged as well before we do anything, because this thing's a bit of a beast, and from my memory there's a good bit of plate voltage on this amp. It's 60, it's just, yeah, it's not a deal in there. Let's just check the others, but they've got balancing resistors on because these are in series, so they're probably drained. Yeah, there's only 4 volts in those. That's good, nothing to worry about there. So what we're going to do is change these capacitors, these bypass caps, to 22. That's the next job. Right, I've got the caps in, and more want to focus this video on what this amp will actually sound like when we've put these 22s in, but also just a bit more on this bias trim pot that we're looking at here. So we are going to add in a 22k resistor. And the first thing we're going to do is snip off this lead here, because we don't want this connected. So we're going to cut that, and like so. Right, we've connected up the bias pot correctly now, and basically what we've done here is we've disconnected the bias pot at this end. We've cut the leg off. We've flattened down the extra lug on here so it can't make contact. We put a 22k resistor in from the AC feed, from the winding for the bias. That goes through the diode, then comes through this 47k resistor to ground. And then what we've done is we've paralleled the pot on there. So if the pot fails, the resistor will remain in place, the 47k. And bearing in mind that you can do this on a lot of amps that have got a similar circuit to this, but the values may well be different. So remember, this is a Burman. This is only for these Burman amps. So what we're going to do now is power this up. Now I've took the output tubes out, and it would be unwise to power this up without them. If you've got a standby switch on the amp, then you can just leave it in standby and switch it on and you'll be fine, just to make sure you've got the correct bias voltage. But we really need to make sure it all functions correctly first before we even think about putting the tubes in. Right, we're ready to power it up. I have it on the current limiter, and we've got a fairly low wattage bulb in there because but obviously we've not got the output tubes in. So we've got some bias voltage there. You can't see, but we'll bring that just into shot there. Stand up properly, don't be facetious. Meter, word of the week, facetious. So -8 there. We've only got a 15-watt bulb in, so we're going very steady. I'll drop a 40 in now, and you can see the bias voltage is coming up there. And we've got -20. We've got 148 volts going into the amp. We're only drawing 100 milliamps, but again, we've got no tubes in there. First thing to see is if, let me just put this on manual focus, is to see if it works, and we can adjust it, and we can by the look of it. So we'll put it on maximum. So that's looking reasonable. Now I want to see just how much voltage that we can get on this before we put the tubes in. So I've gone up a bit more on the bulbs, and you can see now we're already up to nearly -40, and we're just about there and climbing. So it looks like we've got more than enough bias voltage. Just turn it down. Yep. Stick a 100-watt bulb in now. There we go, we've got 203 volts in there. Bias is going up. Now it's settled. -38. That's a 150-watt bulb, and that's given us 232 volts going in. The -43. So what I'm going to do, be very careful what we're doing in here, because there is a lot of plate volts, because those tubes are not, there's no output tubes in, so you won't be drawing any current. So you need to be very careful when you're doing this. You need to be careful anyway. So we've got -40 there. And you have to be especially careful when you're working on these, because look what's right next door to the bias pot. The diodes are right next door. We're going to let's try and run this. I don't think that's stiff enough to do it. Now you can see what I've done there. I've run the bias pot over that paper and disconnected it. Look at the bias volts go up there. So what will happen is that this amp will run cold, and now that's without the bias pot, negative 53. So even if we set this and let's just say we need negative 35, it'll still go to 53 when the pot fails. The more negative volts you have on the grid, on pin 5 on the grid, the less current you have on the tubes. So the tubes will run cold. That's the idea. And you'll see when I pull that, and I'm just going to, not that this is massive protection, but I'm just going to put this glove on. If I pull that out, you can see the bias voltage goes down. So that way it'll protect the tubes if the bias pot fails. And it could simply fail because it just gets dusted there over time. It gets oxidized, it just doesn't connect. Where before, that pot, let's just go in with something, that pot was doing what this resistor's doing, basically. And so if that would have failed, the tubes would have just gone up. No bias voltage on the tubes, they just go up straight away. The fuse would blow eventually, but the tubes would be gone. So that is how you do the bias mod. So basically we'll go through what we've done there. The problem with this amp again now, we've not had the output tubes in, so before we go over this problem we're going to check for voltage, because the tubes normally burn off most of the power when you switch it off. They're still conducting, and so they eat the voltage. Now I think we'll be okay with this because it's got balancing resistors and they act as bleeders, bleeding resistors. So let's see, there's still 43 volts in there, so our voltage is going down, but it's going down slowly. So whilst there's nothing that's really sinister in there, always check, never assume, otherwise you might get a nasty belt off it, and it may rearrange your hairstyle. And if you hear that chirrup in the background, that was Pink, who is looming round, and I've got a very keen eye on her while we've got this on the bench. So let's look at this bias pot then. So the white wire you can see there is the AC feed coming from the winding, the bias winding, goes through this 22k resistor that we've put in there, and that drops the voltage to the bias voltage to a reasonable level. Otherwise, if that resistor wasn't there, we'd just have way too much. It goes through the diode, then goes through the resistor. There's a wire going across there, and that resistor goes to ground. So that'd be your basic circuit, and that's similar to what we had before, except this was doing what the resistor's doing. Now when you've wired that up, you need to, this is then disconnected. We've disconnected this because the white wire was feeding this side and of the part of the track. We've disconnected that, moved it to here, cut this off, and we've just used that as an anchoring point to mount our resistor at one end and the wire that feeds it. And then we come across here to this side, and it's wired on where the diode is. So the pot's disconnected. So what you do to put the pot in parallel with the 47k resistor, you just create these loops. So you go from this connection here, and you loop it over to one side of the 47k, and then the other connection on the pot is on the back here, and you just do the same with that to the other side of the resistor, and you've wired it in parallel. and parallel halves the resistance, which is why when we disconnect it, the resistance doubles, and the more resistance we have, the more bias volts we'll have, because there'll be less bias voltage going to ground. The smaller that resistor is, the more bias voltage bleeds off to ground. So we're now ready, and we're going to put it on its coldest point. We're now ready to put the tubes in. So we're going to set it there. And we'll just... Right, I'm just going to drop down to a 100-watt bulb. Here we go. Bulb's gone dim. Let's check the bias. Volts. Put this one here. Negative 39 we've got there. .170 volts going in, so that should be ample bias voltage. Just wait till we get some sound out of the amp, which we should do. It may take a little longer than normal. Drawing 200 milliamps, and if we look here, now someone asked me about this meter I've got on the wall here, and what this meter actually does that I've got here. Well, what this does basically is monitoring the voltage that's coming in off the wall socket, and it displays the wattage, which we've got at 34.5 at the minute. The kilowatt hour, which is just because it's designed to measure how much electric's being used as well, but we don't really bother with that, so we don't really need that. And then we've got the voltage displayed here. We've got the hertz, which will be 50 hertz, which is standard for UK voltage. And then we've got the readout here, which is the current in amps. So 0.20 amps is 200 milliamps. And then we've got the capacitance there going on. So that's what that meter's for. And this has... for the capacitance, this has a hole going through it, and what you do is you feed your live wire through that hole and then connect it in underneath. And what that does is, that I think is to measure the capacitance, if I remember off there. I think that's what that's for. I forget now. But anyway, let's just see how we're getting on with this. So we've got sound. So we'll go up with the bulbs. We've got 250 watts of bulbs now. We'll just check this. And we've got negative 46 in there. Now remember, when we were checking that before, we were on the bulbs. We still are on the bulbs. Negative 46. So let's go up to the two 150s. So now we've got yes, pink, we've got the two 150s in. Negative 46. The amp's very quiet because it's running quite cold. So what I'm going to do is bring this up slightly. And now I can hear the thing swaging a bit more. So that's negative 40 now we've got on there. So we've come off the bulbs and we've got negative 41. So now we're going to check the bias. Let's just bring that down. Sorry you didn't see any of that, did you? I was testing. Keep forgetting to move the camera. Anyway, so now we need to check the bias. That's just the camera causing havoc. So we're going to pop this in here. It's made of plastic, so it'll be fine. And these again are quite easy to check the bias. We turn the volumes down. So we've got the primaries here on the transformer, you can see on the output transformer, and we've got center tap here. So if I go off center tap, and you've seen me do this before, so we've got 0.9 volts on that side, and we don't seem to be getting anything on the other side. Oh, we do. 0.8 near enough on there, so that tells us that that's still quite low. Now we need the resistance on there. I may well have that in my notes, but we'll have to check it again. So we'll check those, but I can tell it's really cold. Let's just feel that the tubes, well, yeah, they're cold, not the lukewarm. So let's switch off. So 0.9 and 0.8, we don't have to be rough at this stage. So we're going to let the voltage drain out of the amp, which is what we need to do to get a good reading off there. So let's just see where we're going. Yeah, now you can see the voltage has come down much faster because the tubes are in already. We're down to 14 volts there and dropping. 11 and so on. Yeah, so that's coming down. So we'll just give that a couple of minutes to fully drain off, and then we'll go in and take the impedance readings each side of the transformer. Right, so we'll take readings on each side. So the white wire is the right tube, the red wire is this one. So let's try and prop that up so it's not, the light's not shining on it. There we go. That's, oh, I thought that. So let's measure. Actually, sorry, the green. No, hang on a minute. What am I doing? Sorry, the green wire's on the left. The white wire's on the right. The red is centre tap. It's even marked centre tap there. Duh. So let's see what. Put it on resistance, and you'll get a reading. $43.5K will do us nicely. Oh, there we go. 43.5K for green. Right, let's go to the other one. $41.6 for white. So now we just need the plate volts, because we know we've got 0.9 on green and 0.8 on volts drop on white. So we'll move this meter, we'll switch on, let things warm up a little bit, and we've got 479 volts now on there. 479. Right, let's add it up. Let's just start with so 0.9 divided by 43.5 is 20 milliamps, times 479 is 9.9 watts. So we're in a window. We just need to go up a bit more, don't we? So we'll go about there. And we'll see what we've got now. So we'll go with green. Now I've got 1.6. See what we've got on 1.4. So we'll go with the 1.6. 1.6 divided by 43.5 is 36.7 milliamps. We're not going to be far away at that, I wouldn't have thought. We're getting closer, and the plate volts is 473 now. 17.3. Bang on. 17.3. That'll do me. So just do the other side now. 1.43. 1.43 divided by 41.6 times 473 is 16.2. So they're a little bit out. So they're about a watt out. That's acceptable. So that's it. That's biased, as easy as that. So yeah, that's how the bias mod works. The amp's cooking now, and should that pot fail, then the voltage will go up to 50 odd volts. The tubes will just go cool, and obviously the amp will sound terrible, which will alert the user, or the customer in this case, that there's a problem with the amp, like there is with this gimbal. It's rubbish. I could use a worse word, but not on the channel. Right, so we've done the caps, we've done the bias pot. So if you've got one of these amps, that should have helped you with that one. It's just a good one to do. Improves the reliability of the amp. The power switch, well, I don't know, there's nothing wrong with that as I can see, so I don't know. Knowing my luck, the customer will take it back and within a week it'll have failed again. A little bit of frying though, I've noticed. I'm hoping that's not a plate resistor or something. Yes, just a bit of frying. I don't know where that's come from. Seems to have gone now. Keep an eye on that. Oh, that's the reverb, because the reverb's not connected up. Swaging some gain. Not a lot of frying, just a little bit. We'll just see if that clears up. The customer never said anything about that. I'll have to keep an eye on that, because it could be a cathode resistor, and the reason that may not have been there before, of course, when I've changed these bypass capacitors, we've obviously had heat on the resistor. We've got to, because they go across the resistor. So that's something to keep an eye on. But what we'll do now is we'll give this a try with these 22 microfarad caps on and just see what the overdrive's like. So we'll switch off. Right, so I'm just going to record this a bit different to what I normally do here. I'm going to put the camera on the controls so we can see, again, for anyone who's got one of these, can see a bit more of the settings now we've changed these caps. So let's just get some bass on there, treble, presence. Nice clean tone. Turn gain 3 down, and just that will turn gain 1 up. Let's have half of gain 2 in. sounding better. Again, you really need to get the bass off this, because I think the coupling cap's quite large in this amp, which doesn't help. So that's all the bass out. I've got the treble up to about 8.5. Bass. Half on there. See, now we need a bit more bass there. That sounds very nice there. It's a nice sweet spot. And that's really smoothed that out now. It's not as farty with the 22s. Drop that down to 7. Bring the mid up. So I've got half the mid in. And you tend to find on these amps, you know, you put the controls in at some points and you don't get a very good sound at all, and then suddenly we've just found, by dropping this to halfway, we've got a nice sweet spot there. Number 10 on the treble. Let's put some presence in. Wow, that's let's bring this down to number 7 and let's put some more bass in. Gaining on 1. So that's sounding quite tasty now. Let's put all the bass in. And you see, as soon as you put all the bass in, it gets 40. So we need to keep that out. But then, to be fair, you tend to get that on Marshalls and things. You need to get the bass out when you're, certainly on the older ones. So let's, you can see that frying now. That could be a bit of a problem. That may well be a cathode resistor. The thing is, if this, I'll have to check with the customer, but if this wasn't frying before, the only things we've had the iron on is the cathode resistors. Let's still there, even with all the volumes down. That is, we'll have to have the tubes out, preamp tubes out, and just clean the sockets. Anyway, we'll worry about that later. So let's go full on gain 2 now. You can see now. So the best sound that you get from this is when this gain is at halfway, and this is at is anywhere between 7 and 10. And the bass is on about number 3. Take all the bass out and it's empty. So about number 3 on the bass. The mid, well, probably get away with a snadge more bass now. It's getting a bit, yeah. But if you, that's if you like a really tight sound, just put it all in. So that's where I think that's best. About halfway with that, and then we can regulate this. So we'll go. Bring that down. Bit more bass. Having the, you know, the way this is laid out with these couple of gains and things, you're going to have to find a sweet spot with this amp, because I just can't get onto that last note at the end of the tapping on line. Too slow. Too rusty. So yeah, that's sounding pretty damn tasty. So that's full up. Number 8. Number 5. Right, number 3. And obviously we're going to have to start bringing up a bit more. So let's set it back up for a clean sound now. So this demo's getting a bit long, but let's put some bass in. Plenty of bass on there. Probably won't be as much as there was before, but going from 100 to 22. Sounding pretty cool, so we can still get a lovely clean tone out of it as well. Just that frying that's appeared. And this is the problem with old resistors. You put the soldering iron on them and yes, that's quite so what I'll do now is I'll case it up, but before we do that, I'm going to have these tubes out and clean the pins, get the wire brush on the pins, clean the sockets, and just see if we've got a problem there.